According to National Electrical Code Section 215.2 at-war, conductors in multi-wire branch circuits must be identified. The neutral conductor needs to be white or gray. The equipment grounding conductor must be green or bare copper. The remaining ungrounded conductors must be identified by any color other than white, gray, or green. Therefore, re-identifying brown/orange/yellow wires as black/red/blue is allowed under the NEC. Local electrical inspection authorities may have additional requirements. They may require the replacement of conductors with proper color, which would be black/red/blue, to ensure proper identification and compliance with local codes. In summary, the NEC allows the re-identification of conductors from brown/orange/yellow to black/red/blue, but local electrical inspection authorities may require new conductors to be pulled to meet the specific requirements. When dealing with electrical installations, specifically changing from a 480-volt three-phase load to a 208-volt three-phase load, there are several critical aspects to consider regarding conductor identification and compliance with the National Electrical Code, or NEC, as well as local electrical codes. Firstly, let's delve into the NEC guidelines regarding conductor identification. The NEC provides a standardized approach to ensure safety and clarity in electrical systems. As per NEC Section 215.2 at-war, in multi-wire branch circuits, the neutral conductor must be identified as white or gray. This standardization helps electricians and maintenance personnel quickly identify the neutral wire, which is crucial for proper circuit functioning and safety. Furthermore, the equipment grounding conductor must be green or bare copper. This is a non-current carrying conductor that provides a path for fault current to return to the source, thereby tripping the circuit breaker and preventing electrical shock hazards. The green color is universally recognized and ensures that this conductor is never mistaken for a current carrying conductor. Now, regarding the ungrounded conductors, which are the wires that carry the electrical current to the load, the NEC mandates that they must be identified by any color other than white, gray, or green. This allowance provides flexibility while still preventing confusion with the neutral and grounding conductors. In the specific scenario presented, the question revolves around whether brown/orange/yellow conductors can be re-identified as black/red/blue. According to the NEC, the re-identification of these conductors is permissible. This means that using methods such as color-coded tape or paint, electricians can mark the existing brown/orange/yellow conductors to signify that they are now functioning as black/red/blue conductors. This approach is acceptable as long as it is done correctly and the re-identification is clear and permanent. However, it is crucial to understand that while the NEC provides a baseline standard, local electrical inspection authorities have the power to impose additional requirements. These local authorities are responsible for ensuring that electrical installations within their jurisdiction meet a higher level of safety and compliance, often tailored to specific local conditions or concerns. In some cases, local electrical inspection authorities may require that new conductors with the proper color coding, which is black/red/blue, be pulled instead of re-identifying the existing brown/orange/yellow conductors. This requirement is often driven by a desire for uniformity and ease of future maintenance. When all conductors are correctly color-coded from the outset, it reduces the risk of confusion or errors during subsequent electrical work. The decision of whether to allow re-identification or require new conductors often depends on the specific policies and interpretations of the local electrical inspection authority. These authorities may consider factors such as the age of the existing installation, the complexity of the electrical system, and the potential for future modifications when making their determination. To ensure compliance and avoid potential issues, it is imperative to consult with the local electrical inspection authority before undertaking any electrical work. This consultation will provide clarity on the local requirements and ensure that the installation meets all applicable codes and standards. Ignoring local regulations can lead to costly rework, delays, and potential safety hazards. In the context of changing a 480-volt three-phase load to a 208-volt three-phase load, there are other considerations beyond conductor identification. Firstly, it is essential to verify that the existing conduit is appropriately sized for the new conductors. While the question mentions that no change in conductor size is required, it is still prudent to double-check the conduit fill requirements as per the NEC. Overfilled conduits can lead to overheating and insulation damage, posing a significant fire risk. Secondly, the equipment itself must be suitable for the new voltage. Electrical equipment designed for 480 volts will not function correctly and may be damaged if connected to a 208-volt supply. It is crucial to either replace the equipment with models rated for 208 volts or use a step-down transformer to provide the correct voltage. Thirdly, the overcurrent protection devices, such as circuit breakers or fuses, must be appropriately sized for the new load. The ampacity of the overcurrent protection device should match the ampacity of the conductors and the requirements of the connected equipment. Using oversized overcurrent protection devices can allow excessive current to flow, potentially damaging the conductors and equipment, while undersized devices may trip unnecessarily, disrupting operations. Fourthly, the grounding system must be properly installed and maintained. A properly grounded system provides a low impedance path for fault current to return to the source, thereby tripping the circuit breaker and preventing electrical shock hazards. It is essential to verify that all grounding connections are secure and that the grounding conductors are of the correct size. Fifthly, all electrical work must be performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. Electrical work can be dangerous, and improper installations can lead to serious injury or death. Hiring qualified professionals ensures that the work is done safely and correctly. Now let's delve deeper into the technical aspects of conductor re-identification. When re-identifying conductors, it is essential to use approved methods and materials. The NEC specifies that color-coded tape or paint must be specifically designed for electrical use and must be suitable for the voltage and temperature conditions of the installation. The tape or paint must be applied in a manner that provides a permanent and easily visible indication of the new conductor identification. It is also important to ensure that the re-identification is consistent throughout the entire length of the conductor. This means that the color-coded tape or paint must be applied at regular intervals and at all termination points. In addition to color coding, it is also advisable to label the conductors with a new function. This can be done using wire markers or labels that are attached to the conductors near the termination points. The label should clearly indicate the conductor's voltage, phase, and circuit number. Proper labeling helps to prevent confusion and errors during future maintenance and troubleshooting. Furthermore, it is essential to document all changes made to the electrical system. This documentation should include a detailed description of the work performed, the materials used, and any deviations from the original design. The documentation should be kept in a safe and accessible location and should be updated whenever any changes are made to the electrical system. In addition to the NEC and local electrical codes, there may be other applicable standards and regulations that must be considered. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, or i.e. the National Electrical Manufacturers Association, or NEMA, and the Occupational Safety and Health Administration, or OSHA. It is essential to be familiar with all applicable standards and regulations and to ensure that the electrical installation meets all requirements. When dealing with electrical systems, safety should always be the top priority. Electrical hazards can cause serious injury or death, and it is essential to take all necessary precautions to protect yourself and others. Always energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. If you are not qualified to perform electrical work, it is best to hire a qualified and licensed electrician. In conclusion, the re-identification of conductors when changing from a 480-volt three-phase load to a 208-volt three-phase load is permissible under the NEC, but local electrical inspection authorities may have additional requirements. It is essential to consult with the local authorities to ensure compliance and to follow all applicable codes and standards. Additionally, it is crucial to consider other factors such as conduit size, equipment voltage rating, overcurrent protection, grounding, and the qualifications of the personnel performing the work. By following these guidelines, you can ensure a safe and compliant electrical installation. Remember to always prioritize safety and to consult with qualified professionals when necessary. The National Electrical Code, or NEC, is a comprehensive set of standards that governs electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect changes in technology and best practices. The NEC is not a law itself, but it is widely adopted by state and local governments and becomes legally enforceable when incorporated into building codes and regulations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for ensuring the safety of electrical systems and protecting people and property from electrical hazards. The NEC is organized into chapters, articles, and sections. Chapters cover broad topics such as general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and communication systems. Articles provide more specific requirements within each chapter, and sections provide detailed instructions on how to comply with the requirements. The NEC is a complex and technical document, and it is essential to have a thorough understanding of its provisions in order to perform electrical work safely and correctly. The NEC is not intended to be a design manual, but it provides the minimum requirements for electrical installations. It is the responsibility of the electrical designer to ensure that the installation meets the specific needs of the application and complies with all applicable codes and standards. In addition to the NEC, there may be other applicable standards and regulations that must be considered. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Electrical Manufacturers Association, or NEMA, and the Occupational Safety and Health Administration, or OSHA. It is essential to be familiar with all applicable standards and regulations and to ensure that the electrical installation meets all requirements. When working with electrical systems, it is important to use appropriate tools and equipment. The electrical tools should be insulated and rated for the voltage and current levels that you are working with. It is also important to use personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Never work on electrical systems while they are energized, unless you are specifically trained and authorized to do so. Always de-energize circuits before working on them, and use a voltage tester to verify that the circuit is de-energized. Follow lockout/tagout procedures to prevent the circuit from being accidentally re-energized while you are working on it. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. If you are not qualified to perform electrical work, it is best to hire a qualified and licensed electrician. Here are some additional considerations when changing from a 480-volt 3-phase load to a 208-volt 3-phase load. Firstly, transformer selection. If the existing equipment cannot be directly connected to a 208-volt supply, a step-down transformer will be required. The transformer must be sized appropriately for the load and should be installed in accordance with the NEC and local electrical codes. Secondly, panel board modifications. The existing panel board may need to be modified to accommodate the new 208-volt circuits. This may involve replacing circuit breakers, adding new circuits, or reconfiguring the panel board layout. Thirdly, motor control centers. If the load includes motors, the motor control centers, or MCCs, may need to be modified to accommodate the new voltage. This may involve replacing motor starters, overload relays, or other components. Fourthly, lighting systems. If the lighting system is connected to the 480-volt supply, it will need to be rewired to operate at 208 volts. This may involve replacing ballasts, lamps, or entire lighting fixtures. Fifthly, control systems. If the equipment is controlled by a control system, the control system may need to be modified to accommodate the new voltage. This may involve reprogramming the control system, replacing input/output modules, or reconfiguring the wiring. Sixthly, grounding and bonding. The grounding and bonding system must be properly installed and maintained. This is essential for ensuring the safety of the electrical system and protecting people and property from electrical hazards. Seventhly, documentation. All changes made to the electrical system must be documented. This documentation should include a detailed description of the work performed, the materials used, and any deviations from the original design. The documentation should be kept in a safe and accessible location and should be updated whenever any changes are made to the electrical system. Eighthly, inspections and testing. After the electrical work is completed, it must be inspected and tested to ensure that it meets all applicable codes and standards. This may involve visual inspections, continuity testing, insulation resistance testing, and other tests. Ninthly, safety training. All personnel who work on or around electrical systems must be properly trained in electrical safety. This training should include instruction on the hazards of electricity, safe work practices, and the use of personal protective equipment. Tenthly, emergency procedures. Emergency procedures should be in place to address electrical emergencies such as electrical shocks, fires, and equipment failures. These procedures should be communicated to all personnel and should be practiced regularly. By following these guidelines, you can ensure a safe and compliant electrical installation when changing from a 480-volt 3-phase load to a 208-volt 3-phase load. Remember to always prioritize safety and to consult with qualified professionals when necessary.